Well, good morning, everybody. We're going to start off this forecast video talking about some of our areas that have recently gone into some pretty serious drought. And I want to talk specifically about a few big watersheds. We're going to get into the forecast, see how things are shifting, especially for the northern plains. We're going to ask if we can get much moisture into some of these very dry areas. I'm going to stretch it out again at the very end to look at the longer term models, some correlations with La Nina, and we'll finish with South America, okay? So first map here, just last 30 days of total accumulated precipitation expresses a percent of normal. And while we have seen some larger storms come through the northern plains here, in fact, this morning we're watching storms go right here through the Red River Valley, which were well forecast. The questions still remains, are we going to be able to get rain here, especially into this epicenter of drought between Iowa, southern Iowa, but most of Illinois and almost all of Missouri. Then the eastern Corn Belt, we do have chances for storms coming through. Are there any tropical systems to be discussing that could hit the south or the southeast, where we continue to see dryness building into the mid-Atlantic and also into the northeast? But I want to start, if you don't mind, over here, because there have been some really good monsoonal storms that have come through parts of Arizona into Southern California. They've been up in Nevada. They've curled around here into Washington, parts of Washington, but definitely Oregon, getting into Idaho. And we've even seen the remnants of tropical systems, like, remember, Juliet came through here delivering some rainfall. But as we think about parts of the Colorado River watershed and then eventually the path of that river, I just wanted to have a quick look at Lake Mead's water level. So it's 172 feet below full pool. It's not uncommon for it to be somewhere around here this time of year. But what I did was, the nice thing about this website is you can overlay several of the previous years, all the way back to 2020. What struck my eye was that as we look at the way that 2025 is coming through, we can compare it to a couple of other years, I think, that are worth noting. Specifically 2023, which was here. You can see it kind of down in the basement coming up in late summer. And then I also want to have a look at a year like 2022, which would be this year here. So we're looking at these crisscross years, trying to understand what it was about the pattern and how did it not only affect the West, but the rest of the world, the rest of the country, excuse me. So let's go back to 2022. All right. This should be a familiar pattern to a lot of us. Deep trough, where Bering Sea, Chukchi Sea, this part of Alaska, with this large ridge that's giving us a blocked pattern from mid-July all the way to mid-August. So the pattern kind of came over the top, dove into this direction. And this is the kind of pattern that would eliminate the best kind of flow for the western states. So if you have a look at it, this is what we end up getting. Can you almost see it kind of connects over the top, but with that cutoff low sitting and spinning here, you get a lot of this going on. Okay, so this is centered on that very dry spot there in the in that part of the Colorado River Basin. All right, I'm just looking specifically here. Now, let's compare and contrast this to 2023. What a different scenario. There was now just a broad open wave here. See this trough? And then we came, over a small ridge that was here and then dove into another trough. This was a much better flowing pattern. If you look at the winds, I mean, there's just flow. See it? And as a consequence of getting much better flow, instead of just pinching off a large ridge here, there's actually monsoonal type circulation coming into this area. And with this particular pattern, we're not starving the rest of the country, at least the majority of the rest of the country, for rainfall, save this part of the southern United States. That was this region was caught out of the best flow, like Texas, which is why it got so very, very dry at the end of 2023 summer. So look, mid-July to mid-August, incredible drought in parts of New Mexico, Texas, getting into Louisiana and parts of Mississippi. Well, I found just something that we have to discuss is, we were talking about better storms here, but this was a very wet corridor, and this was a very wet corridor as well, which includes, back in 2023, some of our major river basins. Now, can you just remember this? Remember 2023 was a wet late summer. Okay, just let's leave it at that. I'm going to come back to that in a second. But if you want to look at this all compared to 2025, this has a whole lot of 2022 flavor to it, okay, if I could say that. So deep trough, where Chukchi Sea. Now again, this is, August into September. Big ridge here, comes over the top, dives into a trough, but there's this blocked, almost Rex block looking feature here. And what that did overall was it kind of, once again, what do we get? We get that high here, absolutely terrible flow through the west. The jet stream is very far northerly displaced. We're bringing in dry air with this pattern, not active flow like we got in 23, just bringing moisture across. And I just always find it instructive to go back and look at these previous years and attempt to make some sort of sense out of what a pattern like this, can do. And so that's where we are. Now, is it going to look the same as what happened in the rest of September of 2023 or the rest of September in 2022? And to be honest with you, the next 15 days is neither. What we do see in the next 15 days is much deeper troughs in the Gulf of Alaska. We see some sort of troughing that's sitting off the southeast coast, but a large ridge that's been kind of pinched in the middle here, which is going to slowly progress with these longer waves farther to the east. Now, the big difference between 2025 and those 2022 and 2023, which were our compare and contrast years, much stronger flow here in the North Atlantic. So this year has its own flavor, even though some of the ingredients that got us to this point look very similar to those, well, especially to 2022. So I do all of that, that gives me perspective, because I'm really trying to understand where we have this drought. So let's come back to it. Now, this drought is older than 30 days, trust me, but my map just goes back 30 days, and I find it to be an instructive one to look again at these very dry regions. Now, I'm going to steal away from the four corner states, because the deficits here, if you look at them, you got to remember there's a difference between a rainfall deficit in summer in the mountains, which can be, measured in tenths of an inch, versus a drought that's in the Midwest, as an example, or the Southern Plains especially, where you start to see 3 to 4 inch 30-day deficits. Or also look at the Mid-Atlantic into the Northeast. But if we zoom in right here, let's just take a look at this kind of north-central view. I want to point out how incredibly dry this particular pocket has been. And why I'm focusing on this is you have, the Missouri, which comes in like this, the Ohio, which comes in over here, and then we've got the Mississippi in the middle. The three rivers and all of their tributaries contributing to the largest system of flat navigable river space on Earth. And what I did this morning, because this continues to fascinate me scientifically, was I wanted to know, what does the river look like going all the way back to the beginning of that USGS station at Memphis? Now, the particular one that we look at in this video was put in back in October of 2014. Okay, so that what you're looking at here is the data from then. And I'm focusing on the zero line here, way down here. And I'm trying to see how often in fall does that river drop below that low level. And I'm also trying to look to see, is there something going on recently that's just dropped all, the river level in total? Can you kind of get a sense that it's doing a bit like this and then like that? Now, of course, the year where it peaks, this is 2019. This was a major, major flood year for the Midwest. But what's incredible is I told you a moment ago, don't forget about 2023. Even though it was so wet in late summer 2023, the Mississippi River in 2023 was 11, 12, 13 feet below low stage. In fact, that was the lowest out of the last 5 years. It was low in 2022. I mean, there it is, 10, 11 feet below low stage. There it is again in 2023. There it is again in 2024. We talked a lot about how dry last, September and October were. And where we are now is this morning almost 5 feet below low stage once again. And the upcoming forecast, well, the storms right now are in the northern plains, and they're going to continue to be here as we go forward. Just take a look at the storms that just crossed the Red River this morning in this area, just looking at some lightning. And on radar, we had multiple rounds of storms that went through there yesterday. So there's our deep trough that's in the west that broke down what had been just near permanent ridging. And we're going to watch this particular setup not deliver the rain we would want into this area to revive the drought situation. Well, to end the drought situation, to revive the rainfall, but instead kind of push more of its moisture here to the northern plains after bringing in over the last few days some very, very large storms into the western states, as you can see here. Now, as I watch this animation, a couple things caught my eye, specifically around my home state of Illinois. I always get asked a lot of questions. What in the world is all of this? Some folks have asked, is this weather manipulation? What's going on here? Why do we not see this when we look at our apps on our phone, for example? Well, this is raw radar data. When you get the app radar, all this is filtered out. These non-meteorological echoes are taken out so as to not confuse the general user of radar data. It's complicated stuff. So if you have a look there, this is what the radar looks like. You can see all sorts of boundary layer effects just in the motion of the atmosphere. There's actually a fog. Some of this, as Matt talked about earlier, some of this is getting, you're actually getting radar reflectivity off of very large cloud droplets that in conjunction are capable of producing, like their net effect, capable of producing enough backscatter to see on radar. But there's everything in here, birds and bugs and dust and all sorts of stuff. In fact, these bright echoes are the wind turbines. And one of the reasons why we can see them so clearly as this animation goes into the overnight hours, and why there's a lot of this interference, is because of the huge temperature inversion that sets up that gives us what is called beam ducting. So instead of the beam going out and away from the Earth, partly due to the curvature of the Earth, also due to the index of refraction of the atmosphere, which bends the beam up as it leaves the radar. Well, if you have an inversion, you can outdo the curvature effect, and what you're basically doing is changing the refractive index of the atmosphere, bending the beam back toward the ground. So it gets ducted, it gets stuck. And you can see all sorts of amazing things like, I'm sorry, I get kind of nerdy about this, but this is fun. Watch the beginning of this animation one more time once it starts over. Because yesterday afternoon, see this ring? That is the lake breeze that left, Lake Michigan. And then the inversion that set up overnight looks something like this morning. So near saturated at the surface, temperatures are something like 20 degrees Fahrenheit warmer, just 500 to 1,000 feet above the surface. And as a result, you get a fog, real dense fog here, but you also get that odd behavior that you just saw in the radar. Now, across the rest of the country, thankfully today's kind of a limited day on high impact weather events, but we are watching the risk of flooding here. There's still some very chilly air in parts of the Northeast this morning as well. And as we just have a look at it, I do want to show you how deep this trough is in the west that's disrupting the pattern we started this video with. And what I'm specifically focusing in on here is this feature right here. So these are high, thin cirrus clouds. And can you see how fast they're moving? Right there, I'm just talking about this. This is the indication on how deep the upper level low is that's going to be sparking, numerous chances for heavy rainfall as this, again, it's just curling up like this, but as this moves out. But the problem is with this pattern, it's not going to be able to move out and then dive into here. There are chances for rain in those drought areas, but they're very limited. By the way, as the sun was setting, we also watched a few rogue storms. These were not well forecast yesterday, moving through parts of the Delta toward Alabama. These persisted overnight. You can see some wildfire, some smoke in Oklahoma as well. But look at this pattern. Look at this thing. That is amplified. And so you're saying, well, why is this not going to just rip through the country? Well, it's too much with meridional flow, too north-south. And so as a result, it's going to concentrate all of its efforts here and not barrel its way through the rest of the country in a manner that would just bring rain to everybody. So the next 7 days, we still have our same narrative. The tropics are quiet. There's a big area in through here that has limited chances of rainfall. We come through parts of Mexico, into New Mexico, into Colorado, low curls up, and that's your corridor of heaviest rainfall. Southwest stays dry as well. Florida continues to be trapped down here with this kind of stationary boundary. They just keep sitting in this area over which we're getting very, very heavy rains as of late. I want to show you just a kind of a multi-model analysis of this. This is the next 14 days by the ECMWF ensemble. You see a very similar story to what I just painted for you. That's the GFS ensemble. So the problem with this particular pattern is these areas that we just discussed that are under rapidly developing drought. And I'm sure a lot of you saw the new drought monitor. In fact, let's just pull this up. I don't know what I just wrote in there. Deep drought. Let's try that again. Drought monitor. There it is. We once again saw just degradation in the drought situation in these key regions we continue to talk about. So after looking at the forecast from both the European and the GFS model, the AIA model looks similar. It does have some differences. I want to show you what it's going to look like in the near term, and then we'll stretch it out a little bit. Severe weather risk is not too high for the next 3 days, but there will be big storms associated with this, as you can see here. And the risk of very heavy rains are detailed in these 3 maps for today on Friday, then Saturday and Sunday. The high-res NAM, it did well yesterday picking up on this. So let's go ahead and continue to use it as we go through the morning hours today, getting into this afternoon, this evening. So as that low just progresses out ahead of it, you have this corridor opening up with the remnants of the storms in the Red River Valley going over Lake Superior. Now, what I will be watching very carefully is what the models do with this, because this has been well forecast. It's this that I want to watch. This is now early Saturday morning. Some of the forecast models, with all the heat that's in here and the destabilization of the atmosphere, are attempting to turn whatever is left over after the convection that just went through here, as it pushes into this area, trying to get it organized, moving it through Wisconsin, Michigan, possibly into Illinois, Indiana, and Ohio. But there's so much dryness in here, it's going to be hard to overcome. But can you see how the models are trying to bring in scattered showers and storms? Again, this is midday Saturday. I'm just watching it. The real show's here. But that's key, because these are some very, very dry regions. And sorry, this just kind of caught my attention here for a moment. This is Saturday night. There are chances of storms. And by the way, you know our forecasting system, right? So if you go to agweather.com, let's click on local weather, and let's just go to Indianapolis. You start typing, it should start to show up there. It is Indianapolis, Indiana. Submit. That's where my little sister lives. And I'm just kind of curious. Don't forget, you can get the National Weather Service written forecast. Hit their API. I'm so thankful they make that public. And again, look, Saturday night into Sunday, there's these chances of isolated thunderstorms. It's going to get hot. 90, Saturday 88. But there's something coming through there that we have to, keep an eye on. All right, just keep going. Look at the depth of this moving out through here. This is now Saturday night into Sunday morning. And that low, you can just see it. It's curling north. It's not moving east very quickly. Now, that is not to ignore other areas like what's coming into the northwest as we get into Saturday night into Sunday morning, and then what might be offshore here. But overall, when you look at total precipitation, I want to compare three models for you. If we play this through this weekend, there's Saturday, Sunday. Take note that the European is also attempting to cascade some storms into this area. It's keeping whatever this feature is off the coast of the Carolinas through early in the week, having the heaviest rains right in through this corridor, which we've now seen why. If we play it later, though, this is now going to be Tuesday morning. The European model is attempting to bring better moisture into the Carolinas, which desperately needed as well. But that's out there next Tuesday, okay? Beyond that, we continue to see the atmosphere 10 days out favoring this region for rainfall. And the GFS has a similar situation. It's also, it's trying to bring in something here Saturday, but it's not as clear as the European. Into early next week, did you notice this difference? Did the European model, did the GFS bring anything into the Carolinas? It doesn't by Tuesday. And what it does is it reinforces the deeper lows that are here. Now, you keep playing out the GFS, it goes out 15 days. So does the new European. I need to make that happen. It's like, hey, let's bring out a hurricane somewhere in here. Remember how it's been doing that? I'm going to show you this in just a few moments. But even at 306 hours, that's all the way up to September 24, there's still a corridor in through here that has very limited chances of getting rainfall. And finally, the AI model. And I just want you to be cautious with the AI model, because as you play it out, you'll notice how it tends to just get wetter the farther out you go. So, for example, if we go back to Indianapolis, we click on 15-day precip. See, we stack them up now. ECMWF, GFS, but look at the AI. So it just keeps bringing in more and more rainfall. Just be cautious with using this model as you go out that far, okay? Just that's all. That's all I wanted to say. All right, so I mentioned the tropics. Let's get back into it. Over the next 10 days, are we seeing any new development? This is a very odd thing to be at this point in the season and not have any major tropical systems in the Atlantic going. But the models are attempting to take some African easterly waves and get them going. I think the issue is, where's the Bermuda High? It's in the shade of red you see here. And what we got is if it stays over by the Azores, which is where it's been, anything that develops is going to curl around that. But my attention is probably not going to be on that part of the Atlantic, but instead on that Central Caribbean gyre. Now watch right in here. Late in the 10-day time period, something is trying to come out of this part of the Caribbean. And I'm curious as to what that might look like and what the models are doing with it. Because we talked about this yesterday. If I play out the GFS, just watch here, okay? Play out the GFS, and it's trying to organize some deeper convection at times in that region. And as a result, you get out there in the forecast about a week or so, and it starts to toss out lows. I'm going to go back and forth, like this thing coming off of Cuba. Right there, see it? Or watch right down here. We see another potential system showing up in the model. You know, it's 10, 11 days from now, but it's like, yeah, bring it on up. And so I'm just going to caution, like, hey, Watch this through the remainder of September. It's one of those years that because of the displacement of the Bermuda High and the heat in the water here, that we start to get these tropical thunderstorms in the Caribbean, in the Bay of Campeche, over this part of Central America and Mexico that just kick off the potential for these systems. They're very low in probability right now, but I just need you to know they exist. All right, what about week 2? If you look across the top, we've got the European model, followed, or first I should say, the CPC European model. We have the AI model, and we have the GFS. And there's something consistent with the models going on in Canada, as you see here. But again, there's this broad stretch. Let's just zoom in on this. That seems to want to keep this region on the drier side of average going out that far. Now, there is something in this pattern I want to pay attention to. And that is going to be two things, I should say. One, how much longer do we continue to pull our flow like this, which we're going to do today? So it's around broader areas of high pressure here and here, meaning we're drawing drier air from Texas into these storm systems, which is what's preventing the heavier rains from getting here. The second feature, I got 3 for you, I'm sorry, is how long does the Bermuda High stay over there? You can see its position. And what's going on in that Bering Sea? All of that needs to be discussed. So first of all, with the first feature, just comparing to a day ago, look at the warm-up we've got. Temperatures are already 10 to 12 degrees above where they were yesterday in this region. We are expecting a very hot day in the central United States, while the west is cooler, the southeast is cooler. This is Saturday. Of course, I'll be in a soccer tournament on Saturday. That's going to be rough on the boys here in Illinois, with temperatures cranking up in the mid-upper 90s. Then we get into Sunday, another scorcher here for this time of year. I mean, just to understand, in Minneapolis, 90 is almost 20 degrees warmer than average. We could see temperatures in the low 70s would be common in this particular area. So we're way up here in the temperature anomaly part. Then we get into Monday into Tuesday and Wednesday. That heat starts to push a little bit farther to the east. Again, this is all driven by cloud cover. So the National Weather Service is also biting into the chance that some of that rain's going to get in here. And then there's a cold front coming through. But what I'm curious about the farther out we go with this pattern is, is there any frost risk in this? Only at high elevation. And did the temperatures late in the month begin to nosedive east? So here's your next 5 days. This is day 5 through 10. So look at the heat coming back into California, for example. We're keeping this region near normal simply because of storms, rain, clouds, all of that. Heat east. And then day 10 through 15, this is where I'm getting a little bit, this is where I am, my idea is different than the models, okay? And this comes back to bullet point number 3 I mentioned a moment ago when looking at those winds. If you look at the GFS, I think that it may have this right. That's the next 7 days. That's week 2. Now watch what it's doing with week 3, which would be the very last week of September. Do you see how it's dropping cooler air in the eastern part of North America while keeping the warmth back here? The reason why I bring this up is that we've been kind of seeing some success with the Bering Sea rule. 17 to 21 days after you see troughing in this area, which we've got, it tends to show up east. The correlation's not perfect. In fact, it's not really that reliable of a rule, but it's been playing out this year. And so I'm curious if we do end up dropping some cooler air, as you see, in the eastern half of the country once we get out there to the very end of September, the beginning of October. It seems to be the case. We just need to keep an eye on it, all right? So we're gonna finish with these longer term models. This is mid-September to mid-October. And again, that time frame, the European extended is seeing more normal rainfall here, but very dry in this region. Now remember, it cannot pick out on any tropical development in these areas. It's not designed to do that. But take a look at the difference between the European and the GFS extended. The GFS is a bit more widespread in its dryness overall. And you're probably asking, well, what model do I use in this case? And I'm going to say this. In late September and October, I wouldn't trust any model for forecasting this region of the country going out beyond 7-8 days because of the tropical season. But I'm curious if we're getting the effects of a La Niña. Like we've been talking about this for weeks. We've got the cold water upwelling. We know we have the stronger trade winds. We've already got dryness in place. See these soil moisture maps just below. You can always go look at these. We looked yesterday at the effect of the warm, region in the Northeast Pacific. And we just have to remember that right now the National Weather Service is saying, going out here September, October, November, December, they've upped the probabilities of having La Nina now above 70%. So historically, when you get into October, November, we just tend to be where the colors are warm. We tend to be drier. It tends to be wet in the northwest and drier in these regions. So that's the historical correlation with this. But I just want to remind you that this color bar goes from minus 0.5 to 0.5, not 1 to 1. So these correlations are not strong, and it's maybe easier to see when you look at this global map of October correlation on precipitation. So we've spent the week looking at all the long-range models. We did that earlier in the week, so you can go back and watch those again if you want, or go look at them on the web if you want. But what I want to do now is just look at these correlations, assuming La Nina is a more dominant factor. And just a reminder that you see the correlations are not overly strong in the United States for October precipitation, but they're a bit more robust in South America, with wetter, farther to the north here and drier farther to the south. Now, thinking that through, what's the European model say is going to be the next 10 days? Well, it's starting to, next week, bring in some monsoonal showers, here. Still has the parked front to the south, but overall we're still drier across a broad section. And if we need to get, 2 inches of rain or 50 millimeters of rainfall to get this going, there's still a broad area that's not going to get some sort of an early start. The GFS is still doing what the GFS has been doing. It's a little bit drier. Okay, that's out in about a week now and beyond. It's trying to way late in the time period, so that's 10 days. That's the same distance out that the European went. So let's compare them. That's GFS. There's European. GFS, European. The GFS beyond this, and most models do this into week 2, just try to bring in rain. And if this does happen, they're going to be planting pretty quickly in Mato Grosso do Sul, and maybe Goiás as well. But the models couldn't be more split in the longer range. This is the mid-September to mid-October outlook from the GFS. It's just very dry. And this is the European extended. It's the same time period to mid-October, and it's got the wetter conditions here and here, not nearly as dry. So I think as we get into October, we're going to have to look very carefully at the planting pace graphics for South America and assess where the rainfall is and where it's not. And we'll try to just understand that pattern going forward. So we have a lot to be talking about here to get us through the middle part of the month of September and October. Okay, that's what I've got for you. Have a great weekend. Stay safe. And we'll talk next Monday. Thanks.